Algebra 2, this is Chapter 4, Section 1. This is going to be working with matrices, not kind of your normal way to work with it, but your book kind of throws this in to get you practice from last chapter, which is solving systems of equations. So they're trying to be sneaky here, but it gets you the idea of matrices also. So in matrices, know that your first element, if they are truly equal, should be equal to this first element, this top element here. And this bottom element should be equal to this bottom element here, no matter how it's written. So that means that y should be equal to 6 minus 2x, and 3x should be equal to the 31 plus 4y. Oops, 4y, not 47. So once you pull that out of there, and you know that the top element's equal to the whole top stuff here, and the bottom element's equal to the whole bottom stuff there, you could then solve this system of equations. And looking at this, the best way to solve this one would probably be substitution. So I could write this as, let me grab a pen here, black. So I'm going to take the bottom one, 3x equals 31 plus 4 times whatever y is. And then I'm going to grab my y, which is the 6 minus 2x. And then I can use my distributive property and solve this feature. So 3x is equal to 31 plus, well, 4 times x is 24, and 4 times 2x would be 8x. Then you want to combine your like terms, so I've got a 31 and a 24, which would be a 55, minus 8x is equal to a 3x. Extend my page a little bit. Then I want to get my x's together. I've got a positive 3x and a negative 8x. Negative 8x is smaller, so I'm going to move it by adding 8x to both sides. And so I get 11x is equal to 55, and so x would be equal to 5. And then I can substitute that back in. So I'm going to grab my top equation here. Y equals 6 minus 2 times 5. And so that's equal to 6 minus 10. So that would be equal to negative 4. So my answer in this case would be a point. It is a point again, so please put it in parentheses. So my x is a 5 and my y is a negative 4. And you could substitute that back in and check and see. So is negative 4 equal to 6 minus 10? And is, this would be negative 12, equal to 31 plus 20. Oh, I think I substituted that in backwards. I did. That didn't make sense. And now I know why, because it wasn't right. So this would be 3 times 5 is 15. Is 15 equal to 31 plus, and that would be a negative 16. And that, in fact, would be true. So they're both true. I did get the right solution. I can try another one for you. Again, this is just the book sneaky way. This isn't really what we use matrices for. But this gets you to solve systems of equations again. So y in this case would be equal to, this y would be equal to this 3x minus 2, because they are both the top element in the 2 by 1s, and they are both 2 by 1, so this works. And then this 3 here would be equal to this 2y plus x. And then you can solve these, and again I would probably solve this by substitution because it's all set up for it. So 3 is equal to 2 times plus x. Put in my y is a 3x minus 2. And then I can finish the problem. So 3 is equal to 2 times 3x is 6x. 2 times negative 2 is a negative 4 plus x. And so then I have 3 is equal to, well, 6x plus 1x is 7x minus 4. Then I want to get x by itself, so I work from the bottom of my order of operations, and I get rid of addition and subtraction first. So I add 4 to both sides, and so 7 is going to be equal to 7x, and x will be equal to 1. Then I'm going to go back up to my original equation here, this one, and y is equal to 3 times 1 minus 2. And so y is equal to 3 minus 2, and y is equal to 1. So my point would be 1, 1. And again, this is a point, so please express your answer as a point. Double checking it to make sure I'm right. Is 1, let's grab blue, is 1 equal to 3 times 1 minus 2? The answer is yes, it is. Is 3 equal to 2 times 1 plus 1? And the answer is yes, so my answer is solid. So again, we're just practicing here, understanding that when you've got two matrices that are the same, then every single element should be the same going through there.